I know exactly what you're thinking. Can I use the ME Mini as basically a solid state home server, media center server, HDMI output, living room PC? Is it quiet enough to do that? It's got Wi-Fi, it's got dual built-in 2.5 gig Intel NICs. Yeah, I was thinking the same thing. So here we are. Let's get on with it, shall we? So look at this thing. It's 4 cores. It's an N150. It's not going to set the world on fire. It's got 6 M.2 ports, 6 M.2 bays. It's got a Crucial P3 Plus 2 terabyte M2280. This is also a 45 watt platform. 45, I'm just doing the math here. It's like 10, 20, 30, 40, 50, 60. Huh. How's that going to work? We'll take a look at that. But also, this has 64 gigabytes of eMMC built in. And if you read the specs on the website, it makes it seem like the eMMC is taking up one of the M.2 ports. That's not actually the case. We also have an E-key Wi-Fi that I'm going to try to stuff a Coral TPU accelerator into. Basically ditch the Wi-Fi and go for a pure wired connection. This could be a reasonable platform for Forbidden Router. It could be a reasonable media server platform. Heck, it could even be a reasonable Proxmox platform. I've certainly run Proxmox on a 4-core N100. This has 12 gigabytes of memory, which is good for a virtualization platform. And believe it or not, the core is, it's only 4-core. Okay, yes, I would love to have the 8-core platform, but 4 cores can get it done. And we've also got the power supply. Now, it takes up to, it says 100 volts, 1.5 amps input. That's a lot of wattage to provide for the system, but it says the output is only 12 volts, 3.75 amps. So that's where I'm sort of doing the math, trying to figure this out. It's got a single fan in the top, though it looks like it would spin this way and pull air in from the top and send warm air out the bottom. I would much rather this fan spin such that it's bringing cool air in from the bottom and exhausting it out the top, a natural sort of chimney effect. But the whole thing is heatsink on the inside, and that seems like that would be a good design for something that will have 6 M.2. Now again, this platform dual 2.5 gig, let me just do the math for you real quick. At most, you're going to be pulling 500 megabytes per second off of this thing over the network. That's not too bad, that's pretty respectable, but 500 megabytes per second is glacial compared to the speed of even a single M.2. Our 2 terabyte P3 SSD here from Crucial can easily do over 4 gigabytes per second read and write, and so it's not going to bottleneck. It's going to always run at a relatively low amount of power. So if you look at this on paper, there's a lot that seems weird and unbalanced, and yet it can still get the job done, mostly. Let's take a look. For display out, you've got a single HDMI, and at the rear, it's pretty Spartan. You've got your 110 volt input because it has a built-in power brick or a built-in power adapter, so you don't need an extra separate power brick, which is nice, especially if you're going to mount this in your media center or with your PC or something like that. Dual 2.5 gig LAN, a single Type A at the rear, and then at the front, we've got another Type A and a Type C. In the box, you've got the unit itself. If you disassemble it like I did, you're only going to take out 4 Phillips screws. This design also lends itself to 3D printability, so you could probably print a new 3D top for it. I was thinking about making this the platform for 3D printed HAL 9000, meaning that I plug in a PTZ webcam and sort of redesign a 3D printable top for this, and then I've got a little PTZ camera that sits on top of this that can look around and do some maybe fun AI stuff. Now the BIOS for this thing is basically fully unlocked, which is nice to see, so if you're going to do any off-label experiments, you could probably do that on this platform. Our Twin Lake ULX N150, 800 megahertz, 12 gigs of memory, DDR5 4800. It's a Micron kit we learned from CPU-Z. The platform supports CNVI, we can see that option here. Discrete Bluetooth interface, sure. We're going to try some experiments with that here in a minute. CPU configuration, efficient core information, 6 megs of L3 cache. Basically what we would expect. Don't see anything super unusual. CPU boot performance, turbo mode, so this platform has all the turbo stuff enabled. It actually, surprisingly, doesn't enable a lot of the thermal functions because this cooling situation is basically overkill. So CPU thermal configurations like the TCC activation offset 17, but proc hot response disabled. The processor's never going to be hot. Proc hot lock disabled. unless the fan dies completely. I'm sort of surprised this is the out-of-the-box defaults on this platform, but it's probably alright. Because remember, the TDP here is 6 watts. Although, the configuration here allows it to turbo to 15 watts basically forever. Here, the platform is configured to put the fan to 100% when the platform hits 90C. So this is not Intel's built-in thing, this is Beelink's built-in thing. So don't think that I mean that there's no thermal management here whatsoever. There is some, but it's from the platform, not on the CPU side of things. But it is nice to see all the options in the BIOS that are exposed. S5 RTC wake settings, you can set this thing to automatically wake the system up at a fixed time or a dynamic time. So it knows the HDMI out is active. It also supports network booting because these are Intel NICs, so you can enable this and then this thing can boot off of the network if you prefer to pull the image from the network. That is an option. Storage video on other PCIe devices. EFI support. It detects our NVMe. Under the system agent configuration, memory configuration, you can see the memory training algorithms and thermal configuration. It's unusual to see this level of exposed options in the BIOS, but hey, I'll take it. You can also configure the PCIe port routing and configuration. This should be fine. You shouldn't have to mess with this. ASPM is disabled out of the box. PCIe power management. VTD is enabled out of the box, which is interesting. This is one setting that you may need to enable for our later Proxmox guide for your GVTG pass-through, so make sure that that's on. This is the graphics settings that seem to work with Proxmox for GPU pass-through if you need it. The kernel version matters a lot. Sometimes resize bar could be a little problematic. You don't really need resize bar for this platform for what we're doing. You can disable resize bar if you are having trouble, and SR-IOV being enabled is a good idea. So those are the settings you'll need if you're going the Proxmox GPU pass-through route. This is our eMMC controller. This is where the 64 gigabytes of storage comes from. You can disable that in the BIOS if you prefer. There is some support on this platform for SATA, so you might be able to use a SATA NVMe. I did not test that. The documentation for this suggests that 2 of the NVMe ports have SATA routed to them, but again, your mileage may vary. I'm not really sure that that use case matters a ton, but maybe it's an option. So for our Linux installation, Windows comes pre-installed on our Crucial M.2, so we can undo this if we want to. I'm just going to start with installing Linux, Proxmox specifically, to our eMMC. So I've got my USB prepared for that. Just going to plug it in that front connection. I've taken out the M.2. Remember, we've still got the 64 gigs of built-in eMMC storage. It's a multimedia card. It's eMMC. It's like having an SD card, but it's built into the platform as opposed to being removable. Similar performance, as in low performance, but for the boot drive or operating system drive, it's fine. And then once we get Linux set up, we can add more Crucial P3 M.2 and set up a storage volume and expose it to the network and have lots of fun.
3 hours later.
Well, the Proxmox installation failed. It seemed to have failed to create partitions on the MMC block 0, but I was able to create the partitions manually, so probably just a bug in the installer script. I guess we'll do that manually. So the reason the installer doesn't work in Proxmox is because they don't want you to install to MMC devices, and historically this has been good advice because an MMC wears out. When you have logs and things that are being written continuously to it, a lot of the time multimedia cards were not really designed for that. In our modern world in 2025, MMC flash is a lot more endurance than it did historically. And there's on-chip controllers to do things like wear leveling, whereas in the past that wasn't really a thing. So I don't know. We're going to give this a try. I mean, keep in mind, this is a 4-core, this is not enterprise. We're going off script here. So in the level 1 forum, there's a guide, and the first thing for the guide, we have to edit the block Perl module on the installer. So basically, as soon as you boot up the installer, drop to a terminal, we're going to go edit this file, and we're going to add another line in here to make it recognize MMC BLK, because that's hard-coded, because I guess that's good design. I don't know. I also ran into another bug where when the disk is completely blank and it has to create the partitions initially, that also fails. So I went to the terminal and I used gdisk to just create a partition, and then I used prox2e installer, prox-2e-installer, and that let it install normally. Now, just for giggles, I tried replacing the Wi-Fi card with an E-key Coral TPU. It's like, hey, what if we could use a couple of those dual TPU modules on this and do some fun AI stuff on an M.2 add-in? It didn't work. Weirdly, the LSPCI output from Linux shows Thunderbolt 4, but using the USB-C port with a Thunderbolt enclosure, I wasn't able to get a Thunderbolt handshake. I'm not sure if that's a me problem or if I should have spent more time working on it, but I don't think Thunderbolt is a thing that's officially supposed to work anyway. I'd say the installer problems are relatively minor, all things considered. You want to make sure that this thing is stable and on your network, because if you do the rest of the guide to enable GPU pass-through, you may have difficulty accessing the local console through the HDMI port. Using this thing as a forbidden router platform, I think you could run 2 or 3 virtual machines on this. I was looking at, can I run a small Home Assistant VM, a forbidden router VM, and a media server VM? And the 12 gigabytes of memory makes that possible-ish. This is a very limited platform with just 4 cores, but if you're apartment living or, small living kind of thing, then this could be an option. It's also going to come a little bit down to pricing. So on the forum, this kind of thing is a really popular sort of DIY setup. The Firebat T8 is another really popular platform for DIYing this kind of thing. And depending on what features you're looking for, that might be a more featureful platform, but also more DIY. If you have a bunch of old M.2s laying around, 512 gigabytes, a terabyte or 2, and you want to add this to the platform and make it network accessible, this is a pretty awesome platform to do that silently and to give you a little bit of flexibility in terms of, okay, I'm going to do the forbidden router thing, I'm going to have a Pi-hole VM, and I'm really going to try to slice and dice it. In my own Proxmox setup here and just doing experimentation and with the N150 CPU, limiting the VMs to 2 to 3 cores at a time, you can oversubscribe things pretty heavily. I had a total of, I think, 16 cores allocated to 4 virtual machines, 2 to 3 cores per virtual machine. And the performance wasn't terrible. Wasn't great, but it also wasn't terrible. For media transcoding and things like that, remember that's not really running on the CPU. That is going to run on the GPU. If you're going to try to do any kind of media transcoding on the CPU, it's not going to be an enjoyable experience. But the iGPU here is quick sync, and you can do a lot with that if you can pass it through to a virtual machine that can deal with media. Of course, if you want to, you can also just put Linux on this natively and run lightweight containers. You could skip the whole Proxmox thing and just set up a Jellyfin media server. If you don't need forbidden router functionality, you don't necessarily want to run Pi-hole. Although it's really not that big of a deal to add Docker or something like that to just a native Linux host and be able to run a couple of lightweight containers on your media server pulling double duty. At the end of the day, if you're running Home Assistant, something like that, then it's going to kind of sort of be containerized anyway. But for this setup, running a small Home Assistant instance plus forbidden router plus a media server plus Pi-hole is basically at the absolute limit of what this platform can do. It's an interesting platform. It's interesting that Beelink has put this together. I suggested to Beelink that they ought to do the 8-core version of this, or maybe like the Core i3 version of this in like 100-watt power envelope, give or take. Oh, power usage. Loading this thing down with M.2, we do get right to 45 watts of power when the thing is fully loaded. Even for a single PCI Express lane, and even for the power envelope, in the future, with 4 and 8 terabyte M.2 being more affordable, maybe the power constraints would be more of an issue. But remember, these M.2 are going to only run at a fraction of their speed, especially if you're pulling things over the network at 250 to 500 megabytes per second, depending on if you use one or both of your interfaces. Now, Crucial P3 SSD is a pretty good SSD. It is designed for like a workstation type usage, and the performance will really bottleneck in this platform. So I decided to run Crystal Disk Mark in Windows just to give you an idea of the performance you can get on Windows from a single drive. Given that this is just one PCI Express lane, we're getting over 1 gigabyte per second read and write. This is just a fraction of what this drive is capable of. This is a great drive from Crucial. But in this platform, because we've got 6 slots, they're basically taking all the PCIe lanes and running one lane to each slot so that you could run a lot of storage in this thing. I mean, you could pack in 24 terabytes with 4 terabyte NVMe. I mean, heck, you could go 48 terabytes if you had 8 terabyte NVMe, but I think that you'd be better off building something a little less compact and that'll be a little bit faster with faster network interfaces if you're spending that much on NVMe. But still, the crucial SSD here is very low power, especially when you're not pushing it very hard. So our total platform power usage right now, just running this kind of a test, is only about 11 watts. Because we're not really pushing the CPU or the GPU very hard. If you're not going to use this in a forbidden router type scenario, you can plug in both of your network connections here, and at least if you have SMB multi-channel enabled, something we've done a video on in the past, when you're pulling files off of this thing, it'll automatically use both network interfaces without you having to set up anything exotic. You don't need a special network switch or anything like that. This thing will end up getting 2 IP addresses on your local LAN. As long as DNS is working correctly, your Windows clients and some Mac clients will be able to establish multiple channels to the host and pull from this little thing at 500 megabytes per second using both 2.5 gig NICs on the platform. I think the downside for a lot of people might be cost, because you can DIY a less expensive solution. There are bare N150 boards out there for less than $100 US. But Beelink can kind of make that up a little bit depending on if they bundle, this crucial 2 terabyte NVMe plus the Windows license is really a significant part of the cost of this. On the one end of the spectrum, it's a Windows machine. You can plug it in your living room and run Windows, use a wireless keyboard, and have a perfectly enjoyable media center experience, and also store all of your media locally on this device, but also leave it accessible on the network. You can run Plex Media Server or Jellyfin or anything like that natively on Windows, or on Windows with just a few hoops that you have to jump through. That's a perfectly reasonable way to use this platform. At the other end of the spectrum, you can go whole hog Linux virtualization platform, and it's surprisingly capable for those kinds of use cases, even though it's only got 4 cores, because it does have 12 gigs of memory. So depending on which way you want to swing with that, I'd love to know what kind of a project you're working on with this, or what ideas you have for a platform like this, because hey, maybe we'll do something fun with that if you have a good idea, or you want to mess around with it, or whatever. I don't know. I'm Whittleless Level 1. It's been a fun, interesting look at a new sort of platform. I bet Intel is surprised by how well the N100, N150, N305 type CPUs are doing, especially in this sort of DIY fun time scenario. I bet that has probably caught them off guard, seeing little machines like this pop up. It's neat. I like the physical design. I like the heatsink. I like the cooling. I like what I see here. I just want a little bit more horsepower. All right, that's enough rambling. I'm Whittleless Level 1. I'm signing out. You can find me in the Level 1 forums. Let me know what questions you have or what else you want to see. All right, I'm signing out, and I'll see you there.